Okay, this video is just on your savings worksheet, and I'm going to go through each problem just really quickly because I have this set up here, so you can feel free to pause the video and check your setup. Just a note, if you have this setup right, but you're not getting the answer, then it's a matter of how you're typing things in your calculator. And that I need to kind of observe during class, so make sure that you bring that up for sure. So number one, I'm also going to kind of just highlight keywords that will help you pick out the formula that you use. So you're depositing into money into an account, compounded quarterly. So anything that's compounded is a money formula. And then you have to ask yourself if you're putting money in once or twice. And it only says you're depositing $800 once. So then you know that you're going to be using this formula, which is your compound interest formula. And then I have everything filled in here. How much you put in, your interest rate as a decimal, you're compounding quarterly, and there's 4 quarters in a year, and you're doing it for 8 years. Okay, the second one, again, you're given $5,000 on your 10th birthday, so you're putting it into a CD, and they're going to compound that quarterly. So again, compounding should imply this formula if you're putting the money in once, and you are. So again, just plugging in everything. So he was given $5,000, and you want to know so how much money should he put in the CD so that he'll have $5,000 when he turns 16. And so from 10 to 16 would be 6 years. That's your time. And then you should get the answer. All right, number 3, Alyssa's putting $300 into an account, and it's going to be compounded continuously. Keyword there is continuously, which should imply the PERT equation, and everything else is fairly straightforward. So she's putting $300 in. That's your principal. 2.45 is a decimal, 2 years, and you should get that answer. Number 4, Josie receives $2,000 from her grandfather on her 10th birthday, and on her 18th birthday she transfers all of this money to an account that is going to be compounded continuously. How much money will she have when she reaches 25? So first of all, her dad puts it into an account and it's compounded monthly, and so that's a one-time deal. So again, you're using this formula, and you're plugging everything in. So the $2,000 is your principal, the interest rate that she was given, and 12 years because she's going from her, 8 years because it's from 10th to 18th birthday. Then that balance gets put into the compounded continuous formula. So that balance is going to go in for the P of the next formula, and that's going to be for another 7 years from her 18th to her 25th birthday. This one is just seeing what the better deal is. So if you compound quarterly versus continuously, and you're putting money in one time, so again, here's your one-time deposit, and obviously the second formula is a continuous situation, if I can spell there. And you're putting the money in, so the $2,500 goes in for the principal, the interest rate, everything is given, so you're just seeing which one is better, and obviously you make more with option 1. All right, here you can just kind of pause the video and check your work, but I'll just comment on a couple things. So you're going to deposit $100 at the end of the month. So at month 1, you're putting it in at the end. Then you take that balance and carry it to the next month. And then to figure out interest, in case that's what you were stuck on, it's P times R times T. So in this first box here, my P is $100 because that's where I started. So I would take $100 times the interest rate, which is 6.5, so 0.065, times the rate. And the rate here, you're doing it monthly, so it's 1/12 because it's always a portion of the year. And you multiply that out, and you apparently get 54 cents. So then you add that on, plus the $100 that you deposit at the end. So you have 100 plus 54 cents plus another 100, and then you keep doing that process. So this number right here, your principal, will be these values as you increase. All right, here the parents of a newborn baby decide to deposit $40 a month. So keyword is it's not just one time, it's a month. So now you know that it is an increasing annuity. And it's compounded monthly, balance after 18 years. So I know my deposit's $40 a month, so I put that in. And the little I is your interest rate divided by n, so it's I can show that 0.06 divided by 12 since it's compounded monthly, and that is 0.005. And then you're doing it for 18 years, and you dump that in your calculator and you get the answer. All right, how much should be deposited? So now you don't know D, so you use the D equals formula into an annuity. Okay, dead giveaway, it says annuity, so you should know to use the annuity formula. And you're going to, anyway, you're going to deposit each month, that's keyword too. And you want to have a balance of $2,500, or 25,000, excuse me. So you put that in for A, your interest rate divided by N again, so 0.075 divided by N since it's monthly, and you should deposit $344.70. Okay, this one is, again, says the word annuity, so you know that it's the annuity formula. It's also $100 per month, so you know that's an annuity. So you're putting that $100 in for your deposit every month. Your little I is your interest rate, 0.07 divided by your compounding rate, which is monthly, and then you get that answer. All right, you borrow, keyword. So borrow means you're doing a loan formula, and that's always your monthly payment formula, the only loan formula we covered. So you borrow $100,000, so that goes in for your principal. Your interest rate is 0.04, so little I is your interest rate divided by 12. So I is going to be 0.04 divided by 12, and that gets you the 0.003. Plug in everything in, you get that rate. So the total amount of payments is going to be that monthly payment times 10 years times 12 months in a year, and that's your total payment. And how much total interest, remember interest is the extra that the bank gets to keep. So they gave you $100,000, you gave them $121,494 back. So that difference is the bank's interest of $21,494. All right, and last one is, again, you're depositing each month. It also says annuity, so you know that it's the annuity formula. And you want to know how much you're going to deposit, so you use the D equals. You know the interest rate, and interest rate divided by 0.04 divided by 12. Just plug in everything in and you get that answer.